All right, you guys, your project is due tomorrow. If this is 2018, that is, if I'm reusing this video in the future, I don't know when your project's due, but it's your little graphing the temperature problem. So I wanted to give you guys a last check if you needed help on what that looked like. I'm just going to go through something, creating the equation. I chose Guildford, UK, and the reason I chose Guildford is because I used to live there. It's a pretty cool town. I think there's some good images here. This first one on the left-hand side, that's High Street. And I lived there. I didn't live, you can't see it in that picture. If you look at this snowy picture, I kind of lived way at the top and I didn't have a car and it sucked having to go to the grocery store, I think was over here, and walking up. Doesn't look steep now, but it was pretty steep up this hill, and I lived at the top of this hill over here. You could get to my apartment from the front side, but it actually overlooked kind of the back side over there, right across from a little pub, the Rat's Castle. Here's some more High Street. It was really cool. Up in this green area back here was a university, Guildford University. If you look at this map, it was right below London right there. So that's the reason I chose this city. And I didn't actually look at the weather, did I? I got so excited remembering where I used to live. If you look at the weather, it looks like today it had a high of 55 and a low of 42. So how are we going to use that to build my sine curve, my model of the temperature? So let's just graph our regular sine of x. Are you okay, Arnie? My dog's making some noises. And there it is right here. So pi over 2 is at 1. That's the very top of the circle. And 3 pi over 2, or 1.5 ways, 270 degrees anyway, almost a complete circle. Here as it goes all the way down to -1. So we're going to change this eventually so that instead of going up to 1, it goes up to 55. And instead of going down to -1, it goes down to 41. Okay? But first, we want to stretch it. Right now, between those 2 points on the graph is 2, right? From -1 to +1 is a distance of 2, right? But from 41 to 55, I think, is a distance of 14. So how do we stretch that? How do we turn that distance of 2 into 14? Well, what we're going to do is we're going to look at half of that distance. We only want to look from the top point to halfway through, which is 0. So that's called the amplitude, and that is just 1. So if we look at here, we want to have the top part be at 55, the lowest part be at 41, and so halfway between those two numbers, which you can do by finding the average, right? So 55 plus 41 divided by 2 is 96, divided by 2 is 48. So halfway between those two values is 48. So we want to figure out how far away is 55 from 48, but also how far away is 41 to 48. And the answer for both of these numbers should be 7. That's our amplitude. Our amplitude is 7. That's the distance halfway between those two numbers. So we can do that. It's the same as stretching any function, as we multiply by that in front. So 7 times sine of x. Okay, so I've stretched it, but now the top part is only at 7, and I need that to be all the way up at 55. So how many more up do I have to do to get to 55? So you can figure that out by doing, right, 55 minus 7, cross that out. I'm going to do this old school style. To 4, to 15, that's 8. And this is just 4, to 48. So I'm just going to add, just like shifting any function up and down, I'm just going to add 48. Okay, and we can't see it anymore because now it's all the way up at 48. So let's get up there. Almost. Oh, good. there's the bottom, which is at 41 now, my low temperature word, that's correct. And my high temperature at 55. So we did that part. Let's try to see this whole, my dog makes the funniest noises, you guys. Okay, so let's try to see this whole thing. Now, basically, we have a correct curve, except remember, here is 48, but this is midnight, right? This is 0. 0 is midnight. And that should be our lowest temperature in this problem. So we have to shift our lowest temperature. We have to shift it over, right? Right now it's at negative pi over 2. We need to shift it over pi over 2, which we can do by moving it to the right, pi over 2. So we'll put minus pi divided by 2, right? So now we have 0, 41. Then at noon, it is 55. And then it goes back to at 2 pi, right? 24 hours later, it's back at 2 pi over 41. So everything's perfect, except the problem, you guys, is we are still in radians. It says 2 pi, but what we really need that to be is 24 hours. So we still have to convert those rotations to hours. So in order to do that, what we're going to do is we're going to talk about our frequency and our period, right? Because in one complete circle, we want one rotation happens in a period of 2 pi, right? So we just want to make sure we know that 2 pi is actually 24 hours. So in front of the x, this is where I'm going to do my conversion. In front of the x, I am just going to put 2 pi over 24, right? In one rotation, 2 pi, we are going 24 hours. So what does that look like here? Yep, 24 instead of the 2 pi. But I know a lot of you did a little more work for it, and what that looked like was, this is what we have right now, 2 pi over 24, right, all in parentheses. If you want to see what it looks like a little bit differently, we can factor out this 2 pi over 24, and when you factor that out, and which means we, of course, put it on the outside, we just have x, right? Because 2 pi over 24 is equal to times x is equal to this, 2 pi over 24 times x, minus, now if I factor out 2 pi over 24 from pi over 2, the question I'm actually asking myself is 2 pi over 24 times what number, right, question mark, but we use x's in math, times what number is pi over 2, right? So in order to solve this, all I have to do is flip this over, multiply it by 24 over 2 pi, the same on both sides. And this cancels, and we get x is equal to, so here my pi's cancel, and then we get 24 over 4, which is equal to 6. So a lot of you wrote it as 2 pi over 24 times x minus 6. And if you wrote it this way, you probably didn't do what I did. You probably knew you had to move it 6. So we changed our frequency on the outside to be for 2 rotations over 24 hours, right? That's our frequency, and we need to shift it 6 hours because 6 hours is a quarter of a day, and that's how much we needed to shift it. Regardless of how you did it, your end result, okay, let's see if it comes out the same. 7 sine, so some of you did this, 2 pi divided by 24 on the out, whoops. 2 pi divided by 24, oops, stupid Desmos, parenthesis, x minus 6 plus, so this one's going to be black, plus 48, and it's the same curve. Okay, those two are equal to each other. However you want to do it, it's up to you. You can put the frequency on the outside, but then you have to factor that on the inside. Since mine was in radians anyway, I just chose to do the conversion right there on the x. Okay, but what's going to happen is you're going to have a different number here for your amplitude. Mine's 7, yours will be different. You're going to have a different number of shifting it up, minus 48, but everybody's middle part here should pretty much be the same. Should probably be exactly the same. So let me know if you have any questions. If you get to me at the beginning of school, I may be able to help you out. Anyway, have a good night, and I will talk to you guys later.